Hello, ladies and gentlemen. Welcome back to the second part of Chapter 2.2, Assessing Normality, which starts on page 148. Now, I want to emphasize that in statistics, in order for information to be used, we need to check to see if it's normal. If it's normal, that is a good thing, or approximately normal, okay? We never say anything is exactly normal, okay? It's approximately normal, okay? I always use that word approximate in front of that word normal, all right? So there are a couple of methods we check to see if the information is approximately normal. Method one is to construct one of three things. You can either construct a histogram, you can construct a stem plot, stem and leaf plot, a box plot. Those are the three main ones. Now, the one that I stick with and I advise my students to stick with is the box plot. And the reason for that is because your calculator can do all of the work for you. All right. And we want to see that the graph is approximately normal and symmetric about the mean and the median. All right. Let's go through a few things. A histogram, stem plot, or box plot can reveal distinctly non-normal features of a distribution, such as outliers and or pronounced skewness. Histograms and stem plots can also show gaps and clusters. Now, one thing I want to emphasize here, that if it's approximately normal, ladies and gentlemen, you cannot use the word skewed in it. If you say it is skewed, you cannot say it's approximately normal. You can't put those together, okay? They're opposites of each other, all right? So keep that in mind as we go through things. All right, so that's method number one, and I'm going to demonstrate that. Method number two, which is also very easy to do, okay, and this is the other one I recommend doing. In fact, you're going to have to be able to read these kind of normal probability plots to be able to tell if something is approximately normal or not. Super easy to read, okay? Now remember, you have the power of pause and rewind if there's something you don't get, all right? And you can go back and rewatch things as many times as you need to. That's the cool thing about all of this. Everything is there at your fingertips. Even when we get close to the AP test, you can come back and you can review this stuff right here, all right? So we're going to look at constructing a normal probability plot, and we're going to use the calculator for that. Well, what is that? A normal probability plot provides a good assessment of the adequacy of the normal model for a set of data. The basic concept here is that we will plot each data point against the corresponding z-score. This is so cool, okay? I get excited with this stuff, and I'll show you with the calculator. It's so cool. The calculator actually finds all the z-scores for you, but I'll get there. Okay, we will have the calculator do that. If the data distribution is close to normal, the plotted points will lie close to some sort of straight line, like a linear line, folks. Remember linear from algebra? Okay, now, again, this is out of your book, and there is no handout, folks, so ignore that part. Okay, if the points of a normal probability plot, again, I just emphasize this, lie close to a straight line, the plot indicates that the data are approximately normal. Systematic deviations from a straight line indicate non-normal distributions, and we'll look at some pictures, and I would advise putting those pictures in your notebook. Outliers appear as points that are far away from the overall pattern of the plot. All right, here we go, folks. I'm going to give you an example. Remember, you have the power of pause and rewind. All right, so we're going to look at Cavendish and the density of the Earth. All right, here we go. So I'm going to do both methods, and I'm not going to write anything on the screen here. I'm just going to go through the calculator stuff, but you put stuff down in your notebook, please. In 1798, the English scientist Henry Cavendish measured the density of the Earth by careful work with a torsion balance. Cool. The variable recorded was the density of the Earth as a multiple of the density of water. Interesting. Here are the 29 measurements. Now, to save time, ladies and gentlemen, I already typed them into the calculator. Okay, I typed all 29 of those in list number 1. Okay, so the first thing I'm going to do is I am going to look at a box plot for this. Remember, don't use the histogram on the calculator. If you're going to do a histogram, I would suggest doing it by hand and just use the calculator to sort your numbers. Okay, so I'm going to throw the histogram out on this. So I advise sticking with the box plot and with that normal probability plot I'm going to show you whenever checking for normality. Okay, on the AP test, they've never said you have to check for normality in this way. No, they've always said check for normality, and I always advise either the box plot or the normal probability plot, and they're both just as easy with the calculator. All right, so I've got the data typed in. I'm going to go to my plot, so second y equals. Okay, you need to know this like the back of your hand, ladies and gentlemen. There's a lot of stuff we're going to be doing with this. All right, I'm going to turn my plot on, plot number 1, and I'm going to go down and I'm going to go pick, remember that first box and whisker plot, this one right here, that one will show you outliers. Okay, it does that 1.5 times the IQR, and then it does the math and it figures out if there's any outliers there. All right, so I'm going to pick that one. I need to make sure I have list 1 there. Leave your frequency as 1. And leave your mark as a box because that's the best. And then remember, we go zoom. Oops, for some reason that does that. I gotta go out of this screen first. I'm gonna go zoom 9. Voila. Okay, now you cannot, that is definitely approximately normal. Yes, the left whisker is a little bit long, but that doesn't mean it's skewed, okay? Only something that is really, really out there, okay, is like skewed. This is approximately normal, folks. And now remember, if I hit the trace button, I can then look at the 5 parts of that box and whisker plot. So there's my minimum, there's Q1, there's the median, there's Q3, and there's the maximum. Okay, there are no outliers. So, and yes, that whisker's a little long, but this is still approximately normal. And if you want to see, if you want to compare the median and the mean, remember you can go stat, calculate, and look at, do number 1, make sure it's in list 1. Okay, there's the mean, 5.4479, and if I go down, that's going to be a little bit smaller than the median. Okay, the median is 5.46. Okay, they're pretty close to each other. Okay, but I knew that the mean was going to be smaller, a little bit smaller than the median because of that left whisker. This whisker, remember, it's stretched out. Your mean is going to be smaller than your median. Now, if there were outliers on both sides of that, it would be a little bit harder to tell where the mean is. You'd have to go in and actually look. Okay, so it's approximately normal, looks pretty good. Now let me show you the other plot. All right, so it's in the same spot. Go second y equals, okay? But this time we're gonna go to the very, very last one, and you gotta use your right arrow to get there. That very last one, this 6th one right here, that's your normal probability plot. Click on it, make sure your list is list number 1. Now, here you have a choice. You can either have the data axis as your x-axis or your y-axis. Leave it as your x-axis, okay? Technically, it doesn't matter, but just leave it as your x-axis, okay? Then remember, we're gonna go zoom number 9, and look at that. Oh, that is a work of art. It's pretty straight, folks. Well, we already knew it was approximately normal. And here's the cool thing. You ready? Remember, this is plotting the z-scores. Okay, x minus the mean divided by the standard deviation. Check this out. I'm going to hit the trace button. Oh, look at that. That 0.4.88, the y value, that's your z-score, negative 2.11. Whoa, that is so cool. The 5.07, the z-score for that one is negative 1.62. See how it's below this x-axis? These are all negative z-scores. Okay, those are all negative z-scores. Okay, and if I keep going, there's the next one and the next one. And as I approach that x-axis, obviously it's going to get closer and closer to 0 because those are closer and closer to the mean, right? Oh, look, there's one that's exactly the mean, okay, or very close. The z-score is 0. All right, so it's fairly straight, okay? It's actually pretty straight. Therefore, that is telling us that it is approximately normal. All right, so that's all we were doing with that. So let's take a look at a few other things here. Okay, there are examples in your book, and I emphasize this almost every single time. There are examples in your book. You need to be reading those examples and going through them. Those are my expectations. Those are also College Board expectations. Now, something else I haven't emphasized enough. All of you have Khan Academy accounts. Okay, if there is something that I present to you and you still don't quite get it, go to Khan Academy and see if you can find it on Khan Academy. Eventually, I'm going to pull in Khan Academy quite a bit with videos on Schoology, or I'm going to try. And there's videos on the College Board website that I'm going to start putting in Schoology here, hopefully within the next few weeks also. All right, there's lots and lots of stuff out there for you. If what I show you, you don't quite get, you can find it. Khan Academy, look at the College Board website. All right, let's look at a few details here. So this is dealing with example 2.13 on page 150. Please read it. Now, I would suggest writing these down. So if the dots like do a pattern like this, okay, where it's curving up this way, that indicates that it's skewed to the left, okay? Skewed to the left. Obviously, the straight line, anything that is pretty straight is approximately normal. And then this one, if it's curving like this, that indicates that it is skewed to the right, okay? The dots are kind of going like that. Now, again, in the book, there are lots of different examples to look at. Okay, for example, here's 2.14 on page 151. We can definitely see that that is skewed to the left. But I want you to read that example and look at that picture again, okay? Here's example 2.15 on page 152. Okay, that one definitely looks pretty linear, folks. Let me go back to this one over here quick. Okay, it looks like these might be possible outliers for 2.14. Okay, so it's also, you can also see if maybe something looks like an outlier. Just want to point that out. All right, here's a little funny that you can look at. Many pluggers fit the normal curve when it comes to distribution of weight. Weights are approximately normally distributed, folks, believe it or not. Heights are approximately distributed, the height of people. All right. And again, there are some more things I want you to look at. These are in your book. You can definitely see, folks, we've got an outlier on this one. If it wasn't for that outlier, I would say that this is approximately normal. Why is there? Now, the question is, why is there an outlier? Was that a data point that was a mistake? What caused that? Okay, is there just some sort of abnormality there for whatever reason that it's there? Okay, these are things that lead us to more questions, all right? Obviously this one, that's pretty linear, okay? That's approximately linear. Okay, here's another one. Well, this one is definitely skewed, folks. It's definitely skewed to the left, and we definitely have an outlier. Now, let me back up a second. This one, if I leave that point in there, I would have to say it's skewed to the left, because if I do this, it's gonna go up like that. That's skewed to the left. All right. All right, here's one that's a little bit weird. It's doing both things. So it's definitely not normal, okay? Because if it was normal, it would be approximately straight. And we got all kinds of things going on. The left tail and the right tail are doing some weird things. Okay, so on this one, I might actually want to look at if I have the data, I want to look at a box and whisker plot. Maybe it might tell me more, but it's definitely not normal. Okay, and that was it, ladies and gentlemen. So that is the last part of chapter 2. So we'll be doing the multiple choice portion of the test over the next few days, and the free response test will be coming up. All right, ladies and gentlemen, good luck.